Welcome everyone to Bleeding Code. I'm John Jardine, and in today's video I'm going to show you how to monitor for asynchronous transactions in your application. Whether it be code you write or third-party modules you're consuming, the type of tools we're going to use in this tutorial will allow you to listen for any kind of asynchronous transaction taking place. We'll also be able to identify the type of asynchronous function being triggered, which allows us to link back to the phases of an event loop cycle. All of this empowers us to potentially make tweaks and adjustments to our logic to work better with an event loop process and bring our applications one step closer to performing at an optimum level. So let's get started. The first thing that I want to introduce you to is a module native to Node called Async Hooks. This module provides an API that allows us to monitor for asynchronous resources that take place in our application. With a few lines of code at the beginning of our app, we'll be able to listen for any kind of asynchronous transaction that occurs while our application is running. Now, the setup of this hook is actually quite basic, and I wouldn't be doing it justice continuing with theory talk. So the best thing to do is actually just jump right into the live demos. So let's go. So here I have a very basic Node application and a couple of samples that allow us to see the async hooks in action. So let's start with something very basic. I'll show you how to set up your first hook. The first thing we do on top is we will require async hooks. Now remember, this is native to Node, so you don't have to install this as a dependency. I'm also requiring the fs module over here because we are going to be using the fs.write_sync in order to write to the console, and I'll explain why in a little bit. Then the next thing that we do is we actually go and create the hook, and it's async hooks.createHook. The parameters that we provide is an init callback, and this callback will provide us, it will return to us the ID of the asynchronous transaction that occurred, the type of asynchronous function that's occurring, and the trigger async ID. You would consider that the parent ID, what triggered it. All right. And once we've got all that information, we can then also return the execution context by running this function over here that will get returned into ID, and we can print all of this out to the console using fs_write_sync. And notice at the bottom over here we have to run the .enable. So once our hook is in place, we can then just go and start testing some functions. So and the first one that I have over here is a very simple timeout that doesn't even do anything. So let's go see this in action. So on the console, we can see that a timeout, that's the type of asynchronous transaction that occurred with an ID of 2, was triggered by its parent 1, and that's just because it was on the root. So the root is 1, and then everything from that will get a unique identifier that will be greater than 1. And then the execution context is 1. I will be honest, at this time, the execution context is blurry even for me, and I don't really focus too much on it. I'll include it inside the console logs, but I'm not really going to focus on it. The other thing that I want to mention is you can pass a fourth parameter over here, which is resource, which will provide you a link to the actual asynchronous resource that was triggered, which can provide you obviously detailed information about what occurred in this example about the timeout. But also for the rest of this demonstration, I'm not going to focus too much on the resource. Now, coming back to this task type of timeout, you might be asking yourself now, okay, how many types of asynchronous functions are there in Node? And the answer is pretty simple, because at the core, these are the following task types that are identified by NodeJS themselves in their documentation. And I will provide a link to this documentation in the description. But the truth is, this does not make up all the task types in its entirety. There are additional task types that can be registered, and you will see that in the demonstrations to come. Now, before we move on, there are two items that I want to focus on before we get to the next demos. The first one is, why did I use fs.write_sync instead of console.log? The answer is because console.log, even though it's synchronous by most accounts and for the purposes of our applications it's considered synchronous, the truth is it does trigger asynchronous transactions. In fact, it triggers up to 3 asynchronous transactions depending on when it occurs. And if we had to use console.log inside this init function, we would land up with an infinite loop, because the very thing that's writing to the log is a transaction in itself, a synchronous transaction in itself, which means the init function is just going to loop and loop and loop, which is why we resorted to fs.write_sync, because it's 100% synchronous and won't cause any kind of weird infinite loop. But just to show you what I mean by console log being asynchronous, I'm going to comment out set timeout, and I'm going to replace it with console.log. I am a console log. I'm going to save this and rerun it. And we can see over here 3 asynchronous tasks were triggered. One of them related to terminal, signal wrap, and then the process next tick were all triggered just by this one console log. So you can understand why we didn't use it in here. It would cause an infinite loop. The second item that I want to bring to your attention is the hook that we're using here from the module is pretty cool. It gives us what we need. But in the real world, when you're trying to run some performance tests and you're trying to isolate where problems could occur or where you could make necessary performance improvements, you don't want this just running for every asynchronous task that's inside your application. You want to isolate it to maybe a specific function. So the logic that I've written over here doesn't really give us that option. The truth is you can extend this logic, the actual async hooks, in order to provide you that capability. It's rather complex. I myself have not done it. I don't have the time to do something like that. But the good news is we have a Mr. Ashley Davis who has provided us with that functionality. And he's made it available on GitHub, and I will provide links to this repo as well. But he calls it an Async Debugger, which is just a very basic Node module that I've already included in my application, and we're going to start using moving forward. But essentially what he does is he creates a wrapper that allows us to actually only monitor from a specific function moving forward, okay, and all its children and all functions that are called within it, which is perfect. It's exactly what we need. All right, so I will provide links to this. Thank you, Mr. Ashley Davis, for that. So that will move us to our next demonstration. Now, in this one, I call it the usual suspects because over here, I've got the 5 asynchronous functions that you would normally use in your code to work with the event loop processes. All right, these are set timeout, set interval, set immediate, process.nextTick, and promises. Now, if you're not too familiar with these 5 asynchronous functions, I actually have another video that goes into detail about how you would use these and how they work with the event loop process and where they fit into the phases of an event loop cycle. I'll provide links to this video at the end of the video, at the end of this tutorial, as well as in the description. So don't worry, and it's definitely worth a watch. Now for these transactions, what I want to do over here is I just want to show you a couple of extra task types that can be identified using these over here, as well as how we use the Async Debugger in order to test out these functions. So again, I added it to the lib folder inside my project, and you can see on top here, I'm no longer requiring async hooks, but rather I'm requiring Async Debugger from that library. And I instantiate a new instance of the Async Debugger. Now the only thing to note when using this is you first want to write all your core root logic first, and then at the very end you will then trigger the Async Debugger by running the start tracking function. It has 2 parameters. The first one is just an ID. It's just an ID, like in my case, I just put test over there. And the second parameter is the function that you want to monitor. So now remember, we're not monitoring everything anymore. We're actually only monitoring a specific function and anything that function works with. Only those asynchronous transactions will be managed. So in this case, I'm going to start with the next tick. We've already tested a timeout, and the truth is set interval will also return a task type of timeout. So both of them exist as a task type of timeout. You've got test immediate, that will return a task type of immediate. Next tick will be a tick object, and then a promise is a promise. So let's test the tick over here and node. So we can see over here the console logs are a little bit different. I've added more detail. I actually went into his logic and I provided a little bit more detail. So we can see over here that a tick object was added with an ID of 3. It belongs to a parent of 2 with a context of 2. Very nice. But then we also see that it was removed. So that's pretty cool. It's nice to see how these functions got triggered and then they were removed. And the reason was it was destroyed. Okay, so that's cool. That's gonna give us a bit of insight. Let's try one more over here, which is the promise. So we're going to add that over there, and we're going to rerun this. Okay, so interesting. Notice that when we do a promise.resolve, 2 asynchronous promise task types were triggered. Okay, good to know. You would have thought that it was only 1, but it was in fact 2. And this leads the way to the next demonstrations that I'm going to provide you. And that is, nothing is as simple as what it seems. Sometimes we feel like we're just running one asynchronous function, but the truth is we're actually running more than one. And we'll see that in the next demonstration. So over here we have, we're going to perform an I/O related asynchronous function. And in this case, we're going to read the file. We're just going to read the package.json. And once again, we're using our Async Debugger, and we're putting it at the end over here, and it's the same ID of test. And all we're going to do over here is we're going to reference this function we've created, which read file, which just performs an fs.read file. Thank you very much. Let's clear this. Node 3. All right. So what do we have here? For one read file function, we see 4 of the fs request callback asynchronous tasks being triggered for that one read file. All right, so this is what I meant earlier on. We are now moving into an area where asynchronous functions don't seem so simple anymore. They are made up of multiple asynchronous tasks occurring behind the scenes, even if they are duplicated, as it was in this case. All right, so that's just another example demonstrating that. Now let's go to some external operations. So what we're going to do here in this demo is we're actually going to run a couple of third-party modules. In this case, Axios, which is a brilliant promise-based HTTP library. I use it for everything. So we're going to do a GET request using Axios. We're going to connect to a MongoDB using Mongoose, and we're going to run a bcrypt operation. So these are third-party libraries, and let's see what they are doing behind the scenes whenever we call them and consider them one asynchronous task. So let's start with bcrypt. And all we're doing over here is we're generating a salt and hashing. Are we on 4? Okay. So we can see over here, random bytes request was triggered. Very nice. But notice, bcrypt salt async worker, and then bcrypt encrypt async worker. If we go back to the documentation, that is not part of this list that's provided with the Node.js docs, and that's what I meant earlier on when I said that these are the core types that sort of Node identifies, but then it seems like third-party libraries can register their own asynchronous types. So this is not the be-all and end-all of the asynchronous types that occur, and the bcrypt just showed us that now, that they have their own sort of IDs in terms of the asynchronous types that they are triggering. So that's what I wanted to show over there. But now check this out. We're going to do a simple HTTP GET. All I'm doing is I'm referencing my website. I'm doing a GET request. Okay, fine. Let's see what happens over here. Okay, wow. Look at this. Look at how many asynchronous transactions occurred just for that one GET. I mean, that's quite insane. Can you imagine how busy the event loop is, how many ticks had to occur before this entire operation completed. Okay. So what I felt most of the time was a simple one asynchronous function GET request turned out to be at least 20 different asynchronous tasks that were running behind the scenes, all from promises to TLS wraps to all kinds of stuff. All right. So there's some complexity in some of these tasks, and I thought this was a great demonstration to show you what's happening. Finally, if we want to connect and disconnect to a Mongo database, also a number of, look at that. There's a number of asynchronous functions that occurred as a result of that, because here's where we started. Look at all of this. Okay. So some of these tasks are quite complex. Anyways, so what's the bottom line with these demonstrations? Well, in the real world, when you want to start testing yours, you are ultimately going to have a function somewhere in your application. That function might be calling functions within functions within functions, running synchronous and asynchronous logic. You decide where do you want to start monitoring for asynchronous tasks. At the root of that function, or do you want to drill down deeper? That's entirely up to you. At least with what I've shown you today, you are empowered to manage the monitoring and the listening for the type of asynchronous tasks that are occurring. And this is how you start understanding what your code and what third-party resources are actually doing behind the scenes. This is where you can start saying, okay, how can I start making tweaks and changes to see how I can better work with the event loop process for better performance, for more concurrency, whatever it is that you're looking for. I want to take a quick moment over here, and if you are enjoying this video, please give it a thumbs up. Please give it a like on YouTube. I'd really appreciate it. And if you like this kind of content and you want to see more content like this, be sure to subscribe to my YouTube channel, as I will be bringing, I'm hoping to bring out at least content related to Node.js, React, Mongo, APIs, integration, hopefully on a weekly basis, but at the very least every second week. So be sure to subscribe. So for the last part of this video, I want to touch on something important, and that is the event loop itself. Now that we know the type of asynchronous tasks that could occur according to the Node.js docs and according to what we've seen in our demonstrations, the next question is in which phase of an event loop cycle would these asynchronous functions be managed? In other words, the callbacks for these asynchronous tasks. In which phase of the event loop cycle will they be triggered? Okay. So this diagram gives us a tree structure of the event loop, and you can see I focus on 4 primary phases over here. I know there are more phases, but these 4 I'm primarily focused on. That is the timer phase, IO polling, check phase, and close phase. Now I first want to focus on 3 of these. That is the timer phase. We know that set timeout and set interval are managed in this phase. All right. And if this is not making sense to you, again, I have a video that explains this in detail, and I will provide a link to it in the description, as well as at the end of the video. Look for it on top here somewhere. It will be prompted. So the timer phase is where set timeout and set interval, their callbacks are managed, and the micro tasks of next tick and promise. Okay, so we know that next tick and promises occur in every phase of an event loop cycle. So we saw in our demonstrations that the task type, the returned, was timeout. So that is connected to both timeout and interval. Now let's go look at the check phase. The check phase, this is where set immediate is managed with a task type of immediate. All right, so we know that. And again, we have the micro tasks of next tick and promise, which have task types of tick object and promise. Finally, on the close phase, we have close events that occur as well as process.exit. And an example of the types of tasks that would occur here would be shutdown wrap. And again, we have our micro tasks. Now, coming back to the question, which type of asynchronous tasks will occur where? Now, the reason why I showed you the timer phase, check phase, and close phase first is because the answer is I can't guarantee where these other task types are occurring, and for 2 reasons. Number one, if you go and watch any tutorial on the event loop and the phases of the event loop, you will find probably for every 10 tutorials, you will probably find 7 to 8 different versions of the truth. Everyone seems to have their own opinion of how the event loop works, and which is a problem because you have to really read between the lines, and you have to cross-reference between multiple tutorials. Okay, so that's the first issue why I can't guarantee. The second one is Node.js themselves. If we go look at the Node.js documentation, when they try and explain the event loop, they themselves do not make it clear which of these task types occur where. Okay, they don't make it clear. What they do say, if we take a look at the documentation, and again, I'll provide a link to this, but what they do say is they tell us that set timeout and set interval occur in the timer phase. Fine. They tell us that the set immediate occurs in the check phase. Happy. They tell us that close events and process.exit occur in the close callbacks phase. Okay, that's fine. That covers the 3 that I mentioned. All right. But now what about the rest? And all we can get from this is that when they mention the poll phase, they tell us that it retrieves new IO events and it executes IO related callbacks. Now hear this. Almost all with the exception of close, timers, and set immediate. So with the exception of close, timers, and set immediate, all other task types, almost all of them, will occur in the IO polling phase. So do you see why I cannot guarantee it? But what we can at least do is we can take that knowledge and say, well, for the most part, we will be correct. like if you follow the 80-20 principle, for the most part, we will know that most task types that are not timer related, check related, close related, or micro tasks will occur in the IO polling phase. So I just needed to make that clear to everyone. So that brings us to the last phase of this tutorial, and I've got a little bit of an Easter egg for everyone. The good news is that the sample code that I've used for today's demonstrations is available on GitHub. And if you go to github.com/bleeding-code, look for the repository NodeJS Performance Optimization. And over there, you'll not only see the sample code that was used for the async hooks for today's video, you'll also see the sample code that was used for testing the event loop phases, which is the other video, which you should be seeing a link above me now that will take you to that video where I explain the 5 asynchronous functions as well as the event loop phases, how everything works together. This is pretty much the one source code repo that will accommodate all these video tutorials that I will be providing. And I will have links in the show notes and the description for this. So I hope this was a great video for everyone and that you didn't really get lost along the way. But until next time, cheers.